Now we are in the second chapter, and in this chapter, we are talking about frequency distribution and graph. If you recall the definition of statistics from previous week, we say that statistics is the process of collection of data, organization of data, and then interpretation of the data in short. So in the first chapter, we talk about collection of data using the sampling technique. Now in this chapter, we are talking about the organization and presentation of data using frequency distribution and graphs. So here, we are going to work on frequency distribution first. When we say frequency distribution, let's see what is the exact meaning of that. You can see to describe a situation, draw conclusion, or make inferences about the event, which is the main thing that we do in statistics. The researcher must organize the data in some meaningful way. So here we are looking at the organization of the data. And the most convenient method of organizing the data is called the frequency distribution. That is the first organization of the data that we are looking at in this chapter. Frequency distribution is the organization of a raw data in table form. So you can see here in frequency distribution, we put the data in the form of table using classes if required and frequency. And there are basically three types of frequency distribution that we are going to explore in this chapter. The first one is called the categorical frequency distribution, which is for the categorical data, ungrouped frequency distribution for numerical data, and grouped frequency distribution for numerical data. So this is the definition and fundamental idea about frequency distribution. Now we are going to explore the example on frequency distribution. Okay, here is our first example. And in this example, we are going to make the frequency distribution for the categorical data, which is not the numerical. So let's see what is going on in this problem. An organization surveyed 50 randomly selected individuals, that is the total number of observation here, and asked them the primary way they receive daily news, how they receive daily news. The choices were via newspaper, which is denoted by N, television, denoted by T, radio, denoted by R, and internet, denoted by I. So these are the four modes with which they are receiving the news. Now we are asked to construct a categorical frequency distribution for this data. So what we can do is we can make a table. So what type of media they are using, you can write that first. So the media are newspaper, television, radio, and internet. So we can do this. Then after we have this, in the second column, we are going to count how many of each type are there. Okay, so we are going to count and write the frequency. For example, how many of these randomly selected people, okay, how many of these 50 people use newspaper as the medium? So you are going to count how many N are there. I hope you can see that. Can you see the mouse moving? I just need yes or no.
Yes.
Okay.
Yes.
So, okay, great. Now let's count how many N are there. Here I have 1, 2, 3. Please follow along with me. Just look at it. 3, then here is 4, 5, 6, 7, 8, 9, 10. We have 10 N, right? So 10 people use newspaper for daily news. Now let's see how many use television. So let's count T here. Here we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 of them watch television for the news. Let's see how many of them listen to radio for news. So the same process, you are going to count. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of them listen to the radio for the daily news. And let's see how many of them browse internet for news. 2, 3, no, it is 2. I'm counting I. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 of them, they browse internet for news. This table that we have created here, this table is called the frequency table. And this is for the categorical data, because the data is categorical. It divides the survey or a sample into 4 different categories. News through newspaper, okay, news using television, news by listening to the radio, and news by using the internet. So this table that is created here, this is called the frequency table. Okay, this is the frequency table for the categorical data. Any question on this one? I'm going to take questions if any. If not, you just say no.
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 Okay. Now here we have the second example on frequency distribution. Let's see what they are talking about. The blood urea nitrogen or BUN count of 20 randomly selected patients, so here the sample size is 20, is given here in milligram per deciliter, that's the unit. We are asked to construct the ungrouped frequency distribution table. When you say ungrouped distribution, you are not making any class. Instead, you are just calculating the frequency for each. And after you construct the ungrouped frequency distribution, we are also asked to do 2 more things here. We are asked to find the cumulative frequency and relative frequency on that table. Let's see what are those things and how we can do this. So we are making the ungrouped frequency distribution. We are not grouping anything. We are just writing the frequency for each number which is here. So when you look at the numbers here, you can see the smallest number to start with is 11. Okay. So let's write the numbers here. Let me call X for the numbers. The variable is X. Now the first number that I can see, the smallest number is 11. Let's count how many are there. 1, 2, 3. That's it. Frequency is 3. How many times it is repeating? That is the meaning of frequency. After that, I can see 12. Let's count how many 12 are there. Here is 1, 2, 3, 4. I think that's it. 4, 12. There is no 13. I don't see 14. If you see 14, let me know. I can see only 15. Okay, 15. Let's count how many 15s are there. Here is 1, 2, 3. Is that right? 315? Okay. I don't see 16. If you see, you can say it is there. 17. I don't see. I see 18. So I'm going to write that 18. And I'm going to count 1, 2, 3, 4, 5, 6. That's it. 6, yes. That is 18. I don't see 19, but I see 20. 20. Let's count how many 20 are there. Here is 1. Here is 2, 3, 4. Is that right? 1, 2, 3, 4. I just see 4, but make sure you double check and verify that. If it is more or less, just let me know. But I saw 4 20s. 1, I'm counting again. 2, 3, 4. Okay, yes. So I got the frequency and the X value. This is our frequency table, but we are asked to do a little more on this one. You can do one thing. We can always find total if we want. Total, we don't normally add the X values, but we add this frequency. If we add the frequency, you can try here. 4 plus 6 is 10. 10 plus 3, 13. 13 plus 4, 17. 17 plus 3 is 20. So the total I obtain is 20. And you can check here. It says 20 randomly selected persons. That means we are doing right. Because if you add all the frequency, that should be equal to your sample size there. Okay, that is your frequency. After you find the frequency, you can see we are asked to find the cumulative frequency. So in next column, we are going to find cumulative frequency. Cumulative frequency means this one. For example, how many 11 are there? You can see it is 3. So we'll write 3 for that. When we see cumulative frequency, we are not just asking how many 12 are there, how many numbers are, or how many observations are there, which is less than or equal to 12. Equal to 12, we have 4. Less than 12, we have 11. So the total is the sum of these two, which is equal to 7. Does that make sense?
Yes.
Okay. Now, the cumulative frequency for this one, meaning of that is how many observations are less than or equal to 15? Equal to 15, you have 3. Less than 15, you have these two, 7. So 7 plus 3 is 10. Now, when you go here to 18, how many observations are less than or equal to 18? That is 6, and sum of all that, that is equal to, how much is that? 16, right?
15.
16.
16,
16.
right. How many observations are less than or equal to 20? That is the meaning of this.
20.
20, right? 16 plus 4, 20. We don't add this. So that is the cumulative frequency. So cumulative frequency will give you the frequency for a number less than or equal to a given value. For example, for 18, when we are looking at 18, we are looking for the frequency or number of observations less than or equal to 18. Okay. In the same problem, we are also asked to find the relative frequency. Here, relative frequency. Let's find relative frequency. So relative frequency, you can write RF, and always remember relative frequency is equal to frequency divided by total number of observation, or sum of all frequencies. I can write like that. Okay, relative frequency equal to frequency for the individual item divided by sum of all frequencies. This sigma sign is sum. So what we do is, for example, in this one, for 11, frequency is 3, okay? Frequency is 3, and sum of all frequencies, when you add all frequencies, that is 20.
20.
So that will be 3 over 20. So what will be for this one? For this, the frequency is 4, so it will be 4 over
20.
20. And then for this one, for 15, frequency is 3, so it will be 3 over 20. For 18, it is 6, so 6 over 20. And then for 20, it is 4, so 4 over 20. You can write the relative frequency as fraction like this, or change it to decimal. By dividing, you can change this to decimal value. So grab your calculator and try this along with me. What is 3 divided by 20? You can divide and tell me the answer. 3 divided by 20. You can use your calculator.
20.15.
0.15, that's good. How much is 4 divided by 20? 0.2, right?
0.2.
Okay, 3 divided by 20, we already did that, 0.15. 6 divided by 20 is how much?
0.3.
0.3. 4 divided by 20, we already got 0.2. So those are the relative frequencies. Now let's try one thing. Try to add these values. Try to add all these relative frequencies and check what you will get. Like the first one is 0.15. Next one is plus 0.2. What do you get?
1.
1. So always remember, when you add all the relative frequencies, it should always be equal to 1. Okay, that is something you need to check, just to check yourself whether you are doing the relative frequency correct or not. Okay, so in this example, you can see we constructed the ungrouped frequency distribution for the numerical data. The data given here is numerical. We constructed the frequency distribution or frequency table, and using that frequency table, we calculated the cumulative frequency, and then we calculated the relative frequency. Later on, these relative frequencies are also called probabilities. Do you have any question on this example before we move on to next example?
Yes.
Okay, what is your question?
Relative frequency, either more than 1 or less than 1. What does mean?
Say that again.
If I get more than 1, I know one here.
Okay, I understand. So if you get relative frequency, when you add all these values, if you get the value more than 1, what is the meaning of that, right?
Yeah.
The meaning of that is we make error in calculation. Because it will always be exactly equal to 1. If we get anything less than 1 or more than 1, then we know that we make some mistake in calculation. Okay?
All right.
Okay, other questions, if any? No question. We'll go to next example now. Okay, here is the example. And in this one, you can see we are constructing a grouped frequency distribution. Okay, we are constructing the group frequency distribution. And we normally make group frequency distribution when we have large number of observations are there. Let's see what is here. The ages at the time of death of those vice presidents of the United States who have passed away are listed below. So these are the ages of the vice president at the time of their death. We are asked to use the data to construct the frequency distribution. And in order to construct the frequency distribution, we are asked to use 6 classes. That is, we have to break this data into 6 classes and also find the cumulative and relative frequency. We already know how to find the cumulative frequency and relative frequency. Now, what I want you to do is look at this data, okay? Look at the data given here and tell me what is the smallest value over here?
51.
What? Say that again?
54.
51.
51.
51 is the smallest? Okay.
Yes.
So you found that the smallest, let me write that. Smallest observation is 51. What is the largest observation?
98.
Say that again, 90, 98?
98.
98.
98. So the largest observation is 98. So your data ranges from 51 up to 98. Okay, it goes from 51 up to 98. Now we have to divide this into 6 classes. That's what you have to do. We have to divide this into 6 classes. So if you try to find the difference, see, remember one thing, it doesn't mean that it is exactly dividing this segment into 6 equal parts. If you think that the calculation will be easy by rounding this to 50 and rounding that to 100, you can definitely do that, okay? But let's try just here. What is the difference between 98 and 51? If we divide that, I mean, subtract that.
47.
It is equal to 47, okay.
7.
So the difference is 47, and we want to divide this into how many classes?
6 classes.
6 classes. So if I divide this by 6, 47 divided by 6, How much is 47 divided by 6?
Gonna be like 7 something.
Approximately 7.8, right?
Yeah.
So I can think of that as approximately 8. Can I do that?
8. Mhm.
Okay. Now, when I make the classes now, we have to be careful here. Now I'm writing the classes. You can start your class exactly at 50 or exactly at 51, or you can start at 50. It's up to you, whatever you want to do. It doesn't matter, okay? You can start at a number a little bit smaller than that. That's totally fine. So let me start at 50. And I am going by the class width of 8. So how much is 50 plus 8? 50 plus 8 is 58. So I'm going from 50 to 58. Let's see whether I'll be able to make 6 classes or not. And then I'm going from 59. How much is 59 plus 8?
67.
67, very good. Then we are going from 68. Okay, we are going from 68, then plus 8. How much is that? 70?
74.
68 plus 8.
76.
76. Okay, I was a little confused. 77, after 76 is 77. So 77 plus 8, how much is that?
85.
85. Count the classes so far. We have 1, 2, 3, 4. We need 2 more, right?
Mm-hmm.
So next one, we are going to start at 86. 86 up to, if you add 8, what do you get?
94.
94. Then you are going from 95 up to 95 plus 8 is how much? 103. So does it include all those information? So are these classes inclusive of all the data from 51 to 98?
Yeah.
Yes, right? Now we need the frequency. Now we need to count the values. Frequency. How many are there? We are going to count. Okay. In the first class, you are calculating or you're counting everything from 50 up to 58. 50 up to 58. Please follow along with me. Look at the screen properly. Okay. 50 up to 58. Do I see any here? 50 up to 58. This is 1, right?
Mm-hmm.
1, 2, 50 up to 58. 3, 4, 5, right?
Mm-hmm.
Yes or no?
Yes.
Yes.
Okay, great. 50 up to 58, 5. Now, I am going to ask you to count how many are there from 59 to 67. 59 to 67, please count. I'm asking you to count now. How many?
1, 2, 3.
Okay, I'm asking you all of you to find this. So what do you got?
7.
You got 7?
10.
10? Look at that. Okay.
Wrong way off. I need to quit.
59 through 67.
12.
How many?
12.
12?
Yeah.
Mm-mm. That's wrong.
4.
4.
Wow.
8.
Interesting.
This 8.
Okay, let's do this.
9.
Let's all look at the screen. Do you have any number here between 59 and 67?
66.
1, 66.
66, 1, right? So let me do that. Any number here, 59 through 67, any?
No.
No.
Any number here?
Yes.
Yeah.
67.
67, okay. Then any number here?
Yeah.
No.
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 No. Any number here?
Yes.
60.
Which one?
60.
60. Okay. Any number here?
Yeah. 66.
Which one?
Twice.
66, right? Very good. 66. Then any number here?
62.
How about
64.
Okay,
No.
62.
62.
And then?
And
64.
62 and 64. Very good.
64.
Any number here?
63.
63,
66.
then 66. Okay. Any number here?
60.
60. Okay. And then any number over here?
No.
Okay, now count. 1,
9.
2, 3, 4, 5, 6, 7, 8, 9, 10. Did I count it right?
Yeah.
Check again. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. Is that great?
Yes.
Okay, now please count. I'm going to give you about 2 or 3 minutes. So please count the frequency for the remaining classes, please. I'm giving you a few minutes here, maybe 2 minutes. Use that time, count the frequencies. Okay, are we ready?
Almost.
Okay. Okay, tell me what is the frequency for 68 through 76?
9.
9. Okay. If you don't agree, let's know, okay? 77 through 85.
8.
10. 9.
8, 9, 10.
9. 9.
9. 86 through 94.
3.
8.
8. Then 95 through 103.
2.
How many?
2.
Did you say 2?
Yes.
Okay. Now, do one thing. Try to add those numbers. Try to add those frequencies. Use your calculator and add. How much is that?
For 86 to 94, I didn't get 8. I don't know.
Say that again. It's not that clear.
43.
I didn't get 8 for 86 to 94.
What did you get?
3.
I got 3. Maybe I'm wrong, but I'm way off.
I got 3 as well.
3. Okay. Okay. I have not done anything. So I'm going to write. Oh, everything is gone. I am just give me 1 second here. Let me erase that 8 if possible. I'm trying here. Life is all trial these days. Okay. Yes. 3, right? Agree with that?
Yes.
Okay.
Yes, but
Yes.
68 through 76 and 77 through 85 are 10.
Okay.
So
68.
the total we should have is 40.
Hold on. Which 2 again? Tell me 68 through?
68 through 76 and
Should be
77 through
10.
85 are 10.
Both are
Those should be
10.
10.
Okay, both are 10. Because I have
We have
not
a total
counted.
of 40.
So now total of 40. Let's see, 30, 35, 40. That's right. And the information given here is also 40, right? 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 40. That's right. Okay, so that should be great now. That's your frequency table. When you add all the frequency, it is equal to 40 because you have 40 number of observations here. So let's find the cumulative frequency quickly because this session is going to expire soon. Okay, the cumulative frequency for the first is 5, right? For the second, it is the sum of these two. 15. So 5 plus 10, 15. Then again plus 10, what is that? 25. Then plus 10.
35.
Plus 10, 35. 35 plus 3.
38.
38. 38
40.
plus 2. 40. Very good. And we know how to find the relative frequency. It is the frequency divided by the total, right? So the first one is 5 divided by 40. Do it in your calculator.
40.
5 divided by 40. How much is that?
1.0.2.
125, right? Next is 10. 10 divided by 40 is how much?
1.4, I think.
10 divided by 40?
5.
0.25, very good.
Yeah.
Same frequency, so 0.25, 0.25. The next is 3 divided by 40. How much is 3 divided by 40?
No idea.
0.075.
0.075, very good. And the next one is 2 divided by 40. What is that equal to?
0.05.
0.05. That is the relative frequency. So you can see that in this one, the only difficulty that we may have is to count those numbers, right? And get the frequency. Now, what I did in this lecture here is I showed the example using the traditional method, how people used to construct the frequency table manually, okay, and how we are still doing that manual method. But in the lecture videos that are posted under the second module, I solve the same examples, but I use Excel to create the frequency distribution. So make sure you watch those videos as well. So whichever method is easy for you, try to use that, okay? It's okay to speak. Yeah. So as I said earlier, the session is about to expire, 45-minute session. We just work on the first part of the chapter, frequency distribution, and we completed this. So I'm going to end the recording now, and also I'm going to end this video. We'll come back after 5 minutes and begin the second recording. Is that good for everyone?
Yes.
Okay,
Yes,
thank you
sir.
so much.